The goal for this video is to understand the factor and remainder theorems and use them to solve problems. The learning objective is to understand the factor and remainder theorems. You need to know what is a factor, how to factorize expressions, and how to divide polynomials. You need to understand that the factor and remainder theorems help us to determine the factors of a polynomial. You should be able to use the factor theorem to find the factors of a polynomial, and you should be able to use the remainder theorem to find the remainder of a polynomial. Factorizing. Factorizing is the opposite of expanding algebraic expressions. It involves finding highest common factors between terms part of an algebraic expression. What is a polynomial? A polynomial has many terms. It can have constants, variables, and indices which can be combined using the four operations. However, polynomials cannot be divided by a variable or be multiplied to the power of a negative index. There are different types of polynomials, including monomials, one term, binomials, two terms, and trinomials, three terms. The remainder theorem. The remainder theorem states that if a polynomial f of x is divided by x minus k, the remainder is equal to f of k. For example, when f of x is divided by x minus 4, the remainder is f of 4. When f of x is divided by x plus 2, the remainder is f of negative 2. When working on questions that revolve around the remainder theorem, you'll be asked to find the remainder of a polynomial by using the remainder theorem. The factor theorem. The polynomial x minus k is a factor of the polynomial f of x if and only if f of k is equal to 0. For example, if the polynomial f of x is divided by x minus k and the remainder is 0, it proves that x minus k is a factor of f of x. Let's go through some example questions to get a better understanding of the topic. For the first question, we have to use the remainder theorem to find the remainder when the polynomial f of x equals 10x cubed plus 4x squared plus x minus 4 is divided by x minus 1. Remember that the remainder theorem states that if a polynomial f of x is divided by x minus k, the remainder is equal to f of k. Therefore, if we want to find the remainder when f of x is divided by x minus 1, we must substitute the value of f of k, which is 1, into the polynomial f of x. Remember when you're calculating f of k to inverse the sign, so if it's a negative, you need to make it a positive, and if it's a positive, make it a negative. So therefore, we're substituting 1 as all the x's in the polynomial. Therefore, we get 10 times 1 cubed, which is obviously 10, 4 times 1 squared, which is 4, plus 1 minus 4, and we get an answer of 11. To check your answer, try using polynomial long division to see if you get an answer of 11 as your remainder. Question 2 once again wants us to use the remainder theorem to find the remainder when the polynomial f of x is equal to 6x cubed plus 3x squared plus 2x minus 3 is divided by x plus 2. When we're calculating f of k, we want to inverse the sign, and f of k therefore equals f of negative 2. Remember, to calculate what the remainder is, we need to substitute the values of f of k into f of x. Therefore, we substitute negative 2 into all the values which are x, and we get 6 times negative 8, since negative 2 is cubed, plus 3 times 4, since negative 2 is squared, plus 2 times negative 2, since we're just substituting negative 2 into x, and take away 3 from that. We get a final answer of negative 48 plus 12, plus minus 4, minus 3, and we collect like terms to make it negative 43. Therefore, the remainder of this is negative 43. Once again, try testing this using long division. Question 3 wants us to use the factor theorem to find out whether x minus 1 is a factor of the polynomial f of x equals 2x cubed minus 3x squared minus 5x plus 6. To do this, we first need to find f of k, and we get an answer of 1 after changing the sign from x minus 1. We need to substitute the f of k, which is 1, into all the x values of the polynomial f of x, which is 2x cubed minus 3x squared minus 5x plus 6. We need to try look out for an answer of 0. If we get an answer of 0, it proves that x minus 1 is a factor of f of x. So we substitute 1 into all the x values, and we get 2 minus 3 minus 5 plus 6, and we simplify this to get an answer of 0. Therefore, x minus 1 is a factor of the polynomial f of x, which equals 2x cubed minus 3x squared minus 5x plus 6. Question 4, again we need to use the factor theorem and find out whether x minus 2 is a factor of the polynomial f of x equals x cubed plus x squared minus 2x minus 8. First of all, we find f of k, which equals f of 2, and we substitute that value into all the x values of the polynomial f of x. Therefore, we get an answer of 8 plus 4 minus 8 equals 0 after adding and subtracting the terms. This proves that x minus 2 is a factor of the polynomial f of x, which equals x cubed plus x squared minus 2x minus 8. Make sure to complete more questions and worksheets based on this goal to get a better understanding of the topic. Thanks for viewing.